हेलो स्टूडेंट्स। सपने वो नहीं होते हैं जो आप नींद में देखते हैं। सपने वो होते हैं जो आपको सोने नहीं देते। Absolutely right. When you prepare for the JEE or NEET exam, so many times you are involved so much in solving the questions, and during that time you dream about your rank. जो रैंक आपको एक टॉप इंजीनियरिंग या मेडिकल कॉलेज देगा और इंजीनियरिंग कॉलेज में आपके ड्रीम वाली ब्रांच। While solving the questions, sometimes you come across very intriguing and complex problems. और तब आपको महसूस होता है कि there is some lacuna in your concepts, in the fundamental concepts. कहीं पे कुछ कमी है जिसकी वजह से आप बस क्वेश्चन सॉल्व नहीं कर। वो क्वेश्चन आपको लगता है ऐसे फॉर्मूला पता है, स्टिल इसके बावजूद भी क्वेश्चन का सॉल्यूशन आपसे नहीं आएगा। यू फील समवेयर सम लैकुना। तो आपके उन ड्रीम्स को जो आप अपने एफर्ट के ड्यूरिंग देखते हैं, उस ड्रीम को फुलफिल करने के लिए आई एम जेबी गुप्ता टू सपोर्ट। मैं आज आपको ऐसी एक या दो एग्जांपल्स देता हूं जिससे आपको पता रहेगा कि कॉन्सेप्ट्स, फंडामेंटल कॉन्सेप्ट्स क्या हैं। आपको फॉर्मूला पता है, इसके बावजूद भी फॉर्मूले को क्वेश्चन से लिंक कराने के लिए व्हाट काइंड ऑफ कॉन्सेप्ट्स यू नीड। सो यू सी, देयर इज वन क्वेश्चन। Calculate the interactive force between the two ideal dipoles P1 and P2 separated by distance R. तो आपको दोनों डाइपोल्स के बीच का इंटरेक्टिव फोर्स कैलकुलेट करना है। In separation between the dipoles is what R. So you see, what will you do? Sometimes students begin to solve it by what they consider dipole minus Q plus Q minus Q plus Q. Then you try to calculate the force of attraction or repulsivity minus Q minus Q plus Q plus Q minus Q plus Q and plus Q minus Q. And that becomes not only the lengthy, through that to get the final answer is also difficult. It is given here that R is much greater than what dipole length. So see, what you need to do here is you consider the electric field E due to dipole P1 in the place where dipole P2 is lying. So E will be equal to 1/4 pi epsilon naught into twice of P1 upon RQ. Twice of P1 upon RQ. Is the electric field due to this dipole P1 in the place where dipole P2 is lying. So now because dipole P2 is lying inside the electric field produced by the dipole P1, its potential U will be, formula U equals to minus of P dot E. So you see, the potential U will be equal to U equals to minus of P. P is what? P2. Is the potential of P2 inside the electric field of what? P1. So yes, that is also true. What is the potential energy of P2 inside the electric field of P1? Same will be the potential energy of the P1 inside the electric field of P2. So U equals to minus of P2. The direction of electric field due to P1 will be in this side because there's the axial position. So minus P2 into E, that is 1/4 pi epsilon naught into twice of P1 divided by R. All right, there's a electric field. There's a potential energy. Now you know that force F is what? F is minus of U by dr. Force F is what? Minus of d by dr. So this is 1 minus. There's 1 minus. This minus and minus will become what? Plus. This minus and minus will become what? Plus, because it is d by dr. You see, du by dr itself will be negative because this is r cube. So this will be r to the power minus 3. So this becomes what? It will become minus of 1 upon 4 pi epsilon naught into twice of P1 into P2 divided by r to the power minus 3. So that will be minus of 3. That means this will be what? You see, this will be minus of 3. It is this minus upon r to the power minus 4. So that will become, this will become what? R to the power. This will be r to the power minus 3. So that will become r to the power 4. Is this clear? And could you understand the sign? Because see, this minus in this formula, minus of d by dr is a force. So this minus and minus to be cancelled. And because here you have differentiation of 1 by r cube, so that will be minus of 3. So this minus will again. Why I'm focusing upon this plus or minus? Because see, sometimes even they give the question in the objectives that force is attractive or repulsive. You know that because this force is negative force, that means it is what? It implies that it is attractive. If this would have been positive, the force would have been what? Repulsive. So I hope this got clear. What we did, we calculated, हमने calculate किया कि P1 के जो P2 यहाँ पे लाई कर रहा है, वहाँ पे इलेक्ट्रिक फील्ड क्या? अब क्योंकि P2 P1 की इलेक्ट्रिक फील्ड में लाई कर रहा, it will have potential minus of P dot E. और क्योंकि P2 और E का डायरेक्शन यहाँ पे सेम होगा, so that becomes P2 into E into cos of 0. Cos 0 is 1. This is a U. Force F is minus of d by dr. You need to keep in mind the proper sign, right? So minus of P dot E, this minus of d by dr. So minus and minus will become plus. Then again in the d by dr, this they will differentiate 1 by r cubed. Again a minus sign will come. So in the final result there will be a minus. I hope this got clear. Now let's look at this one more problem. This problem is okay. So look at this problem. Now look at this problem. So in this problem, what you have is calculate the electrostatic energy in the volume between radius r and 2r surrounding a charged sphere of radius r and charge q uniformly distributed over it. Means आपसे पूछा क्या गया है एक r रेडियस का स्फीयर और इसके 2r रेडियस तक सराउंडिंग में इसके सराउंडिंग में up to radius 2r in this volume, what will be the energy stored? So you know that in the surroundings of a charged body, energy is stored in the form of electrostatic potential energy in the form of electric field energy. And you know it, that energy stored in the unit volume is what? Q equals to Q bar. That is energy stored in the unit volume. Half epsilon naught into what? E squared. But because see, this sphere has a charge plus Q. electric field intensity will be variable. As you go away from it, electric field intensity into distance x from the center will be 1 upon 4 pi epsilon q by x squared. So because the electric field intensity is non-uniform, you cannot multiply some specific amount of energy of unit volume from this entire body. So what we need to consider here? We need to consider here we need to consider what? Some sphere of radius r, right? Then what we did, we considered a spherical shell of thickness dx and of radius x. Electric field intensity in this space will be 1 upon 4 pi epsilon naught into q by x squared. Is all right? Then you see the volume of this spherical shell will be 4 pi x squared dx. So energy into distance x from the center of the sphere in the unit volume will be half epsilon naught into e square. Into what? E square. Half epsilon naught. And it displays the electric field intensity will be this much. Half epsilon naught into what? E square. Right? So energy is the energy of unit volume. So energy of dx volume, this volume of thickness dx will be 4 pi x square dx. You will integrate it from r to 2r. And that will be the total energy up to the radius 2. And this integration you see is very simple. When you solve it, this will become 1 upon x to the power 4. This will become what? 1 upon x to the power 4. Here you have x squared. So this will be 1 by x squared. So dx upon x squared, and its integration will be minus 1 by x. So this will be 1 by x, and limits you can change. This will become what? 2r, 2r. Limits will become what? 2r, 2r. So through that, you can calculate that what is the total energy in the volume between the surface of the sphere up to the radius 2r. So students, just focus upon what? The basic concept. Here also, the basic concept was what? Energy of the unit volume. Then you understood what? Energy in the unit volume is this much, but because this depends on the electric field, and electric field is not constant, it is variable. So you need to consider some spherical shell. You find out the energy of this volume, then you integrate to get the energy of the entire surface, right? So that's all is in this session scripts.